Hello guys, today I will discuss about software defined networking. So first of all, what is software defined networking? So in traditional network, you can see the switch. The switches, they are basically control plane and data plane are together. And in software defined networking, the programmable switch and the control plane and data plane are separated. Control plane in the controller machine and the data plane in the like a normal switch. So the definition should be something like it's an approach to manage the network dynamically and programmatically, so it can make efficient network configuration to improve network performance and monitoring. So let's talk about the origins of software defined networking. So as you can see, in 2004, IETF proposed a RFC, which is like decoupling the control and data forwarding functions, which enhanced the intro, uh, interoperability and design flexibility and scalability. In the same year, a paper called Soft Router. This is the first paper about software defined networking. So in that paper, they separate the control and forwarding functions in the router, and they did some dynamic associations between control elements and forwarding elements, which improve the flexibility and scalability. So let's talk about details about soft router. So here we can see in traditional router, we can see the like the two question: where to send the data, which is control function, and sending the data, which is forwarding function. These two are together. And in soft router, the where to send data is called control element, CE, and sending the data is forwarding element, is FE. These two are separated. So here you can see these are the control element. You can see these are the control element, and these are the forwarding element. These are the forwarding element, and and together it becomes the network element. So after using this, the benefits of using this is like flexibility, and upgrade become made easy because CE and FE separated, so separately can be upgraded. And centralized controls, C's can work together, like you can see the control element here one, like this control element can work together. And the scalability, when network grows, add more forwarding elements. If we need more forwarding elements, you can add more forwarding elements, or if we need more CE, we can add more uh, control element. So in that case, the reliability is when one control element fault or have some problem, then another can take over. And security is easier to protect central CEs than many distributed ones. For example, in each of these forwarding elements, if they have the control elements together, so we have to secure all of these controller. So now the controller is in one place, so we can secure the controller here, and it's easier to protect. But wait a minute, so is there any protocol for separating and deciding the paths for data? The answer is yes. So there was two different RFC 3549 and RFC 4655. So the first one is called Netlink, the second one is PCE. So Netlinks helps separate the control and data parts of the network and makes it easier to manage. And PCE is like deciding the best path for data. And then the internet community find that separating the control plane and is a little bit risky, especially in case of like failure of the control plane. So then in 2007, a research from Stanford University called Ethane taking control of the enterprise. So they defined a single network-wide fine-grained policy and then enforce it directly, and both in hardware and software, both wired and wireless. So let's talk about details in Ethane. So in Ethane, it was centralized control network, simplified switch, and the changes are here. Fine-grained policy improvement. Ethane creates a single detailed network-wide policy and enforce that directly to the central controller. So by details policy, it becomes easier to manage access control and monitor network activities. And then dynamic network management. So controller can adjust network configuration and policy in real time. And policy based routing. So controller use policies determine the best path uh, for data to travel through the network. And authentication, authorization also added. And this is the foundation of SDN and influence the subsequent technologies like OpenFlow. So limitation in Ethane. So centralized control dependency, scalability issues, single point of failure, complex policy management, and limited vendor support and deployment complexity. Then this limitation leads to OpenFlow, which is very popular. And in 2008, OpenFlow came as a robust SDN architecture